So now I'm going to copy those methods, so which I've already written as I said. So I'm going to delete this increment count because it is not needed anymore. I'm going to copy it. Okay, so this is the web3. So as I said, we are using ethers. So I need to import ethers. Import. Okay, so we can very clearly see this. So import ethers from ethers, right? So that is the same plugin that you can see it over here. So it is available in npm. And so what are the advantages of these ethers? Pushkar also mentioned that hard hat is using ethers, which is part of the hard hat framework. Okay, so it is used to connect to JSON RPGs, Infra or Alchemy or MetaMask that we were speaking entire over these 2 to 3 videos. So this is one of the plugins, the good plugins that we had over the community. So I'm using that. Okay, I've just copied the same. So we were using the ether. So we have discussed about check wallet and use effect. So I'm going to collapse them. So now, how do we get the contract? So to get the contract, first what we need to do is, so we have compiled, right? We have compiled our contract, which gives the artifacts. Inside artifacts, we will have the .json, which is the ABA file. So we need to copy that .json to the src folder, because I'm not going to place it in any of the specific folders. I dropped it to the main layer itself. So contour.json, right? So I need to import those two things over here now. I need to import, as you see here, I need to import all those two things, contract ABI and then the contract address. Now I'm going to import those two. So contract ABI is counter.json, which we have at the root level. So, and then contract address that we have opened, right? So let's copy that contract address and then let's place it here. Now, get contract is the method which gives us the contract. What it does, it takes the Web3 provider. You were hearing about Web3 and all the stuff, right? It takes a Web3 provider with the window Ethereum object, and then it signs that object, and then it gets the contract. So why do we need signing? So usually we need our public address that needs to be sent in order to do the transactions, right? So that using the public address, it detects the ETH. If it's just the public address, I can use any other person's public address and then get the gas, right? Instead of me paying from my wallet, I can pay it from others, right? So in order to avoid this, we need to sign our public key. Public key as in the addresses that we see usually. Those are our public keys. So we have to sign those public keys in order to send it. So that is the signing process that it internally does. Usually we have other providers as well where we have to manually sign using the private key. That how we deployed using private key. We have to copy the private key and then do the signing. Ethers internally does this. So we don't need to place our private key anywhere here. Our private key will still lie in our local system. It's still secure. Yeah, that's how we get the contract. And then to fetch the current value, fetch what is the current value. We have a method, right? So that Pushkar has wrote the counter, which is get count. Okay, we'll just use the same get contract.get count. It takes some time, so I'm waiting for it, and then console.log, and then I'm setting this to the local variable where we are using the local variable to display it, right? Okay, that's the fetch current value. Now increment count, earlier we are just incrementing using the state set state, right? So now what we will do is we'll get the contract and then we have the methods that increment. Pushkar has already written. So we call that increment method and we will just say, because usually this takes some time. This, whatever the transaction that you do, it initiates, it goes to the miners blocks and then miners has to validate it. Once the block gets mined, then only the transaction is completed, either successfully or failed. So it takes some time. In peak times, it might take hours also. So that's why we are just showing a message to the customer or the end user. So once the block is mined, the value will be updated. And then we are waiting to complete the transaction. And then we are fetching the value again, right? So once the transaction is completed, we'll update, because in our smart contract, the value gets updated because it's a count plus is equal to 1. That's it. We are done with the methods now. Now the linking is also completed because we are already doing increment count and all that stuff. Now it's beautification time, right? Because there's a lot of waiting time here. We need to wait to fetch the initial value. We need to wait to increment the value. So the user experience has to be interactive on the UI side, right? So I'm going to update it very little changes to the UI using a few, what do we say, beautifications using the CSS that we have already copied. Now I'm going to use the same here. Okay, I've copied it completely. I'm going to remove these listeners because we'll speak about the listeners. Okay, I'm fetching the current value initially. That's how we do, and then we are waiting and then fetching, right? So this is the one. Okay, this contract address we have to copy and then change it here. That's it. Now we'll just do npm start. So it might take little time to run for the initial time. While it is running, let's trim out all the unnecessary things from this folder. Why to keep everything and then make the code messy, right? So I'm going to remove all the unnecessary ones. We don't need test, we don't need all these things. Let's remove all of them. Index.js, let's remove this stuff. We don't need this, we don't have CSS. That's it. And then style.css is custom file that we have created, so nothing to remove. Yeah, we have cleared all the other stuff that is not needed from here. I think it is also running now. Yes, it is also running. So it asked us to connect the MetaMask. So I'm just unlocking my MetaMask wallet. So here we go, it connected. Very simple. Just to show you how this connection works, I'm going to disconnect it again. Disconnect from this account. So whenever I refresh, it says connect to MetaMask. See here. So it is asking me to connect to any of the accounts that you already had. So I'm choosing the test account and then I'm clicking next and then connect. It showed the loader right, and which means it's fetched, right? Because we have this fetch current user which we have added post the wallet connection is successful. So initially right now we have value of 0. Now let me open the inspect menu for you so that we can see the console values as well, and then click on the plus. Right, I just clicked plus. Okay, it is asking me to unlock. I did unlock. See, now it is asking for the gas fee. Let me confirm this transaction. Once block is mined, value will be auto updated. So which means it came here, right? It came to this alert. Now it is waiting for the transaction to get mined and then it fetches the current value, right? Let's collapse all these things which are not required. Yes, now it's waiting for the transaction to get mined and we got the updated value 1. It printed console and then it also printed it here. Okay, it updated in the UI as well. So which means this is working, and then it is not instantaneous because the block has to be mined, right? So now this other approach as well. So it's not good to keep the UI thread waiting or the user waiting till the block gets mined. Here it's just a simple operation, so it took below 1 minute. But usually it takes around some 30 seconds also. In peaks time, as I said, it takes hours, right? It's not good to wait the users for hours and hours just to complete some transaction. So this is the point where we got a concept of events on the Solidity, right? So what exactly events do? So events basically they trigger once the block is mined, once the transaction is completed. Okay, it gets triggered. So on triggering of the events, the same can be listened on the UI front using the MetaMask or the Ethereum object that we have. So we listen to the events and then we catch the values that we got from the events. Now let's see how do we update this event, right? So now it is just very simple. Let me go to the contract here. Okay, we just need to use event. Okay, let me type in. It doesn't take more time. So event. So counter added, and then we give the params. We give the sender address. who triggered this update, and then we send this uint256, the count value, current count value. And what else should we send? I think these two will be fine. I hope so. These two things are fine. Now we just need to trigger once the increment operation is completed. Counter.add. We use emit keyword in order to emit this event, which means trigger this event once the operation is successfully mined. So we need to send the address, the sender address. By default, we have the object of MSG, which is a message, and then TX transaction that are available in the Solidity. So transaction, with the transaction, we can get the gas and then origin, and then with the sender, we can get by default, with the message that we can get by default, the sender as in who triggered this transaction, and what is the gas cost, what is the data it is updating, what is the SIG value, and what is the value that this sender has. So all those things can be got from the message object. Okay, now we are sending who has triggered this update, so I'm using message.sender. What is the value? So whatever the current count value, we need to send that, right? So I'm using just the count variable that we have. So this is a very simple to emit the event. That's it. So the event declaration and emitting is completed now. Now we need to redeploy this contract, and then we need to we need to recompile and deploy to the test network, right? So I'll go one level back, and then I'll do npm run build, which compiles, right? So this compiles again. Let's see if there's any compilation errors. So it's compiling. It doesn't take usually more than a minute. So it successfully completed, one file successfully compiled, because we only have one contract here. Now let's deploy. npm run deploy. Let's copy the it is already giving us a suggestion. Run deploy ring B. Okay, let's just deploy to the ring B network now again, like how we did in previously at the beginning of the video. It's taking time to deploy. Usually, even after it gives us the address, it takes little time in order to get the block mined. Okay, it doesn't immediately appear on the network. It takes little time to get this block mined and get it public. So I've just copied that address. I'm going to change it in the public address of the contract. Now let's comment these two things because we decided not to wait, right? Now we need to write a listener function. Listen to event. Okay. I am declaring it as a secret function using the arrow declaration. All right. Now how do we do this? How do we catch the events? It's very simple. We can use get contract. Sorry, we don't need a byte. Get contract.on. Okay, it's a listener that we had. So first parameter that it takes is the event name that you can see, right? Event name or event filters, and then what the value that the listener is returned. So let's copy the event name, counter added. This is the event name. Now I'm declaring it as a async function, what are the values that we are getting, because the second operator is basically the function. It's a listener function, what are the listened values. So we are sending sender value, and then we are sending the count, and then we are, by default, we'll have the event object. Let's print out all those values to see what exactly we get. Okay, just to make the things easy, let's do it like this. Sender, and then we need count, and then we will print event, the entire object of it. Now, count is the latest value that we'll always have, right? So we will just do set count of count and then .toString. So it's not an underscore value, count.toString. So it updates the count. That's it. We just wrote the listener function now. We just need to use this in the initial when we connected to the MetaMask, when we initially fetched, right? So listen to changes. We will just listen, start the listener at the begin. When we connect it to the MetaMask, it keeps listening in now. That's it. So all our changes were done. Let's see if this block is mined. Copy that and then go to the public addresses and then search for the address. Okay. Once we search, yes, it's created successfully. Block has been mined, and then now it is ready to utilize. Now it's completed. Let's switch back. So all the changes that we did, it is auto compiling it. So now let's simply refresh it. Okay, it is saying some value, some error we got. Ethereum.enable is deprecated, which is a warning, and it is connected. So, but it is saying connect to MetaMask. Let me just quickly open my MetaMask. Okay, it is already connected. It shows it is already connected to the MetaMask. No matching event name counter added. Okay, it's because that we have updated our contract and we have not updated our ABI file locally, right? So we have to, each time we deploy it, okay, we have to get the latest ABI file. Now let me just copy this ABI file and then move it to the SRG and then move, and I'm replacing with the existing one. That's a problem. I mean, that is the error that it threw. Now let's simply refresh. That's it, the error is gone. It is not showing now connect to the MetaMask. It's just that the ABI file has to be changed, which we forgot to do, so we did it right now. Now, so it is connected to the test account, which is the public key that it is giving, and the current value is 0. We might get some error, right? I mean, we doubt that we have already did one transaction. But if you remember, that was on the old contract. Now this is newly deployed, so where the value is 0 by default. Now, let's try to update and see if the listener is catching or not. Okay, just click the plus button. So it navigated me to the MetaMask because I need to pay some gas fee, which is some around 18.57 rupee. Just confirmed it. So once the block is mined, value will be auto updated. So which means it came here, but we are not awaiting now. Now let's wait for our listener to catch the value, because in the listener we have printed this, right? So let's wait for the listener. If you see here, it printed. Sender is this and the current count value is 1. And this is the entire event object. From the event object, it's the transaction receipt, all the blocks, all the gas fees, everything will be available from here. So if in case if you want to utilize any of things, you can use that event object. That's it. So we have done the real transaction now, where our value got updated, and even the UI is so responsive that when you click this button, it shows the loader and then alert also, right? So you can make the UI more beautifying. But this is how we have utilized both the methods, where fetching get count and then increment count as well. So this is how we call the smart contract methods. This is a very basic contract that we created and then we utilized that in the front end. Now, at the same time, as I mentioned that with 3 people, Pushkar, Ruchika and me, we were working in GeekyAnts from the past few months on the blockchain and all the stuff. So we were sharing all the knowledge with you to make learning very easy. Also, we are creating some smart contracts which are complex in type and then also have some real use case, right? So we'll speak about those smart contracts in the coming videos. So do watch watch all of our videos, do not skip out. If you have any feedback or any sort of comments that you have, let us know in the comment section. So we'll try to answer all your comments, and then if at all any videos or any help needed, we are always open to do that. So yeah, we are always active on social media and all the LinkedIn as well. That's it. See you in the next video. Bye bye.